In this video, you will learn how to solve radical equations. First, let's learn about the power property of equality. If you square both sides of a true equation, the resulting equation is still true. Let's look at the example. If a equals b, then a squared equals b squared. And what that means is basically, let's look at a few numbers here. Say we had the square root of x is equal to 4. So the square root of x is a, and 4 is b. Then, if we squared the square root of x, it would have to equal 4 squared. So if we squared it, actually, the square root of x and that squared is equal to x. And 4 squared is equal to 16. So x would equal 16. So it makes this equation would be true. It's the same thing as this, basically, right here. Let's do an example. It'll make more sense. The square root of 7r plus 2 and that plus 3 is equal to 7. First, let's isolate our root. Let's bring 3 over to the other side. So 7 minus 3 is 4. And we have 7r plus 2. Let's square it so that we get rid of this root here. So we have to square both sides. And so this becomes 7r plus 2, and this equals 16. Again, if one side is squared, the other side has to be squared as well. So now we can solve normally like we would to isolate the variable and solve as a normal equation. So I'm going to subtract 2 here, and 7r would equal 14, which means that r would equal 2. Simple, right? Let's try one that might not make that much sense to you. The square root of k plus 1 equals k minus 1. Easy, right? We'll see. All right, first, again, square both sides since we don't need to bring anything over. Square, square. Now this will be a quadratic, obviously, because we're using FOIL to factor this out. But first, let's get this over with. K plus 1 is equal to, this would be, again, first, outer, inner, last. That's FOIL. So it would be k squared minus 2k plus 1. All right? Okay, now, if we were to solve normally, look here. There's a plus 1 and a plus 1, so we can eliminate that. So, and then here, it would be, if we subtracted k here, and we subtracted k here, it would be 0 equals k squared minus 3k. All right? So, if we factor this out, it would be 0 equals k times k minus 3, which means there would be 2 solutions. Now, let's see which ones actually make sense. Right, let's substitute k for 0. Let's substitute k for 0. All right, so if we go back in here to check our answers, and we put 0 as our k. So k can either equal 0 or it can equal 3, because right here, yeah. So let's put 0 in. So the square root of 0 plus 1, which is 1, is equal to 1. So 1 has to be equal to negative 1? Not so much. Okay, this is called an extraneous solution. Extraneous solutions are when we come up with a solution that is not a solution of the original equation. Therefore, we must check the other answer to make sure something actually does add up. All right, so let's substitute 3 into this equation, the original one. So 3 plus 1 is 4. The square root of 4 is 2, and it's equal to 3 minus 1, which is 2. There, so our answer would be 3. And negative 1 would be our extraneous solution. All right? Meaning it's a solution of what we came up with, but it's not a solution of the actual equation. Here. Let's do this word problem. The amount of time t in seconds that it takes a simple pendulum to complete a full swing is called the period. It is given by t equals to 2 times pi times the square root of L divided by 32, where L is the length of the pendulum in feet. It says the giant swing completes a period in about 8 seconds. About how long is the pendulum's arm? Round to the nearest foot. Now clearly this says that we might end up with a decimal or something, so we'll have to just round to a whole number. Alright, so let's take a look at what we have to do. So it's telling us how long is the pendulum's arm. And it says it completes a period in about 8 seconds. So it says the amount of time t in seconds that it takes a simple pendulum to complete a full swing is called the period. So we can find the length by substituting t in for the substituting 8 in for the time. So let's make this 8 is equal to 2 times pi, forgive my messy handwriting, times the square root of L divided by 32. All right? Now, what we can do is divide each side by 2 pi so that we can get rid of this and make it easier to solve. So 8 divided by 2 pi is equal to root L divided by 32. Right? Now if we square both sides, so this side is squared and this side is squared, we're left with 1.62. Hold on, I had to put it into my calculator. So 1.62 is equal to L over 32. Now, what I can do here, it's a pretty clear shot here now. I can just multiply this side by 32 to eliminate and isolate the variable, multiply this side by 32, and I'm left with L is equal to 51.8. And it says round to the nearest foot, so since it's 0.8, we would be converting it into 52 feet. And there's your answer, 52 feet. That is the length of the pendulum's arm. And, well, that's it for today, but just so you know, there are some links that you can find below in the description that I've included. Some stuff from Khan Academy, some games that you can use to practice your math skills, especially on this topic. Thank you.